z-score? Or
Isn't
I
it?
guess we find the z-score
Let's see.
and then the area?
What proportion of the people who take the quantitative portion or above? So yeah, you find the z-score and then use that little, it's that little applet
Yeah.
to find the probability
Okay.
portion.
I need to get a real calculator. I keep doing it like on my computer. Takes forever.
Well, it works all the same, pretty much.
What?
So it works all the same.
I guess it does. It just like I'm so bad at typing, and I feel like it takes me an hour to do. Well, not an hour. It just takes me longer to do like 10 divided by 5. You know, like super simple math. I should just do that in my head, I guess. But divided by 8.8. Brandon, does that make sense?
Yeah, I'm thinking about it right now.
Yeah.
Is it talking about like that I don't know what it's called, that rule of thumb? It's like 95, 97.3. That thing, is that what it's talking about?
Yeah, so it's kind of along that. Let me go back to the thing. So it's pretty much saying what portion of people will take the okay, I'm going to read the question. It's pretty much saying this exact thing, it's trying to ask you, not so much is it if it's 68 or 95 or 99.7, but it's trying to ask you, is it like a 96, a 93, a 92, like a...
Oh, a real definition.
Yeah, sure.
What you end up doing, you find there's like this little applet, and it finds the area under the curve.
Uh-huh.
That turns out to be for this curve. It turns out to be the probability.
Have you seen that applet yet?
Yeah, I'm looking at it right now.
Brandon, have you pulled that up before?
I haven't actually played with it, but I think I know what you're talking about. You put in the numbers, and it gives you a value for it or something. You shade it or whatnot.
Yeah, that's exactly it. So you actually have to use it to find the answer.
Oh.
Yeah, I know. I thought it was like just something to teach you, but then when I was like going through all the problems on like the reading thing, I was like, oh, that's like actually how you solve for it. It's not just a teaching tool.
Oh, so you actually use it then, huh?
Yeah, weird.
Oh, okay.
The alternative is worse.
What did you say?
So the alternative is worse. You have to take an integral.
Yeah, like all this crazy stuff.
Right.
Yeah, I was wondering about that. I was like, I thought it used to be more work, but this is so nice.
Yeah, it'd be a lot worse.
Yeah, I can't imagine that I did that in like high school math though, like the deeper math. So I'm like, I wonder what I did because we didn't have something cool like this.
Mm-hmm.
Okay, I have to pull it up too, Brant. I just realized nothing's pulled up on my iPad, so I gotta go back in and do it all. Hey, how did I... Let's see, individual prep. Read it.
Hey, where do you find that thing at?
Oh, I think it's all actually on the math department website.
Oh, is it
there?
Did you pull it up on the screen, Colby?
Yeah, I can do that.
Oh no, I can't see like the chat right now, so I was like, oh, I wonder if we already pulled that up. And... So, Brandon, it's also in like the reading section. if you go to if you go to like individual prep and then the textbook, it's under section 2.2. There's just a link.
Oh, okay.
Okay, so did you get the Z-score of hold on, 1.613?
Pretty much. I think I took it to 2 decimal places, so I just got 1.61.
Okay.
So pretty much the same thing.
1.61. Yeah, it's pretty much the exact same. Okay, so uh-oh. Did you find that link, Bran?
Yeah.
So what you got to do is you have to calculate the Z-score yourself. Like you take the 165 and you minus the mean and divide it by the standard deviation of the question. And then when you get that answer, which we were saying was 1.61, you go into this applet and you plug the Z-score into one of the sides.
Yeah.
And then it'll pull up that curve. Oh yeah, like Kobe has. Oops, sorry, you can totally see it. And then I thought it was when I was playing with this at first, I didn't realize you could click like wherever you want on the curve and it will highlight or unhighlight it. So just keep clicking above the Z-score where 165 would be, shows you how many would get over 165 or equal to. So that would be a probability of 0.05, so like 5%. Is that right? 5.37%. In other words.
I got. You see, what did you get again?
Like the probability I got, the same as what your screen is showing, 0.0537.
Oh yeah.
And then there's another way of saying that is 5.37% would get above it. If they wanted a percentage.
Oh yeah, yeah. Mm-hmm.
Thanks for following my mind there.
Yeah.
Okay. Brandon, do you have any other questions about that? Sorry, it's kind of hard. We like just do the individual preparation on you, and then but I mean we just do this assignment on you and then switched it. But
yeah, you're good. No worries. It makes sense so far. I mean, it's a little hazy because I did it earlier and I've been doing other stuff, so I kind of forgot. But
yeah, that's totally fine. No worries.
yeah, so far it doesn't seem too bad.
Okay. So part C, if a student scores in the 10th percentile, what would be their corresponding Z-score? Okay, so now we just have to go to that graph. Right?
Yeah, I think so.
So is that the answer then? The Z-score right there?
Yeah, I think I got 1.282.
Hold on, I'm sorry, I'm doing it real quick. So 10% would be a 0.01 area. Is that right?
0.01?
Oh no, that's 1%. Oops.
No, yeah. Colby's
Thanks,
right.
guys. That's why I need you on these group quizzes. Okay. So, did you guys get a negative or 1.28 too?
Yeah.
Okay. Cool. Sorry. Okay. D what is the quantitative GRE score for a student who scores in the 10th percentile? Okay.
I got 139.52.
Okay, 1 second. I'm almost there. Wait, what did you get?
139.52.
Oh, I got the same thing. Awesome. I thought I got it way off. Does that make sense, Brian?
Yeah, for that one, the 10th percentile, are we still using the graph to solve for that then?
Yeah, so well actually they kind of did the question back to back. So let's say we hadn't done part C and we only did part D.
Uh-huh.
We would have to put the 0.1 into the graph like we've already done, and we get the z-score.
Uh-huh.
So we already knew the z-score from part C.
Uh-huh.
But, sorry, I think my screen went blank. But, so you take the z-score, and then the form for the z-score is the z equals x minus the mean divided by the standard deviation.
Oh, right. Okay.
So we just worked backwards to find the x. Mm-hmm.
Okay. Yeah, okay, we're good then. Yes.
Okay. It took me when I was doing like these problems, it took me a second, like they're easy equations, but it just takes a second to figure out how to work in between them, you know?
What they're asking. Yeah.
Okay, so the mean speed of hydrogen at room temperature is 100 or 1800 meters per second with a standard deviation of 600 meters per second.
Mm-hmm.
At room temperature, the mean speed of hydrogen particles is approximately normal with a population mean of... It's got to just be what they gave us, right?
Yeah, I think so.
We have no other way of... I think there is a way, like, farther on. Isn't there... Does anybody know? Isn't there a way to solve, like, the sample mean once you have the population mean?
Not sure.
I thought there was, like... It obviously doesn't matter for now, but I think there is a way. If you knew how many are in the data sample, you can solve for the sample mean. But we can't obviously do that. They didn't even give us the data sample, so, or number. Anyway, a little food for thought there. We might learn later. Okay, what is the probability that a randomly selected particle has a speed over 2,500? So just calculate for the z-score then.
Yeah, do we just have to solve for the z-score and put it in the graph?
Yeah, yep.
And that'll give us our answer?
Mm-hmm. That's right. Did you guys get 1.167?
Yeah.
Hey, can you hang on a sec? I'm going to grab a piece of paper real quick.
Yeah, absolutely.
Okay, sorry.
No,
What-
you're good. All good.
What is the formula again real quick? I'm going to write it down.
Yeah, it's z equals, and then x, or the variable, minus the mean, divided by the standard deviation.
Okay, I keep forgetting the order and screwing it up, so...
You're totally fine, yeah. You have to definitely get that in the right order.
Okay, yep, now I'm on the same page. We're good.
Okay, awesome. Okay, everyone get it?
Yeah.
Okay, so I got 0.1216, right?
Yeah, that's what I got too.
Okay, and then for C, it says what's the probability that will be less than 2,500? So I just took 1 minus what we just did.
Yeah, exactly.
Cool. Okay, so D. Are we all good on D? Okay, or 2D. What is the probability that a randomly selected particle has a speed less than 1,500?
Hey, real quick,
Yeah.
what is our variable x? Is it 1500?
What?
What do we plug in for our variable x?
Is whatever number they're asking you. So like for D, they're asking you like 1,500. So you want to know the z-score. Essentially, when you look at the graph, the z-score is at where the red line is hitting it.
Yeah.
So you're saying, okay, where does 1,500 fall on this bell curve?
Mm-hmm.
And so you are calculating it into a number between like 1, 2, 3, or 4, so on.
Okay.
Yeah, so this would be 1,500 minus 1,800, so negative 300 divided by, what is it, 600? Negative 1/2?
Yeah. Looks like 0.5.
So negative 0.5, so then you just plug that into the graph. And it doesn't matter what side, as long as the first side's negative and the second side's positive. So less than 1,500. So what did you guys get? Colby, if it's up on the screen, I'm sorry to be so annoying. I just can't see the screen, so.
Oh, okay.
I don't mean to be like, so what's your answer? Sorry.
No problem.
Yeah.
Oh, I guess I could just watch it instead of looking at my screen I can do that.
Yeah, I'm just reading off of yours, Colby.
Oh, okay. Then I will join the group. I'm just like over here. So what did everyone get?
0.6915, is that what it is?
Uh-huh.
Okay.
So E, what is the probability that a randomly selected particle has a speed between 1,500 and that? Oh man, I don't know.
Oh.
I got 0.6915.
Uh-huh. How did you do that? Wait, are you on E or D?
Oh, are you on E?
Yeah.
I just that was D, right? Sorry, I thought I did yes.
Yeah.
I just read E. So I got the same thing as you, Colby, though. So you're on the right page. So for E, what is the probability that a randomly selected particle has a speed that is between 1,500 and 2,500?
Question.
Yeah.
So, could we just put the z-score in for each one, and then would that give us our answer? Or would that not be right?
So I think what you do, and Colby, help me explain this if I'm wrong, but my understanding is that you figure out like everything that would be the probability that would be under 2,500,
Mm-hmm.
and then you minus the probability that it would be under 1,500. So then you're going to get that little section that wasn't minused off.
Okay. Yeah. No, that makes perfect sense.
So you'd have to plug in 2,500, the z-score you got for 2,500, and then write down the probability, and then the 1,500. And as I learned, as long as you're shading the same parts of both of those z-scores, they're going to come out the same. So it's fine if you do on the higher side. You know what I mean? Or the lower side, you just have to do one or the other.
Yeah. Okay. Makes sense.
So So I got 0.1672. What were you looking at, Colby?
Let's see.
I
Let's
think.
see.
I
So,
think. Oh, go ahead.
are we? So, which part of the graph are we supposed to look at?
So I think so. The question says, okay, I think you have to highlight. So I messed up when I was in the individual prep. I couldn't understand if you had to highlight like the left side or the right side. So I did one with both, or tried it on both sides. No, so you have to do either like the lesser, so either the left tail and the middle portion. So unclick the right tail. Yeah, so now click the middle and the middle one. Okay, cool. So you have to do either both of those, or you can unclick the right tail and click the left tail and click the right tail. So either one, and then when you switch to the other Z-score, you just have to copy the same.
Okay.
Yeah, and yeah, and I think essentially, I wonder even if you did the middle one, just the middle one, if it would come out the same. You just have to have the same difference. So you just have to do the same for each graph.
Yeah.
So let me look and see. And in the thing, it just said you minus like the bigger one, the lesser one from the bigger one. So I guess it doesn't really matter what one. 1 point. Yeah, I don't think you can do just the middle. I got a different answer, so.
Okay. Yeah, makes sense.
Yeah. Cool. So we did it? Oh, wait, there's still F. What is the third quartile of speeds of hydrogen at room temperature? So what's the 75th percentile, right?
How do you define the third quartile on that graph?
So the third quartile is 75%. So you go to the area and you would put in 0.75.
Okay, that makes sense.
But I think you'd have to highlight, you would have to highlight 2 sections and then put 0.75.
What, like the middle and the right?
The middle and probably the left.
On the left?
Because 75% is saying it's higher than 75% below it.
Okay.
So I got a Z-score of 0.674. Sorry, Colby, I can't. Let me go back to your screen. Oh, why is it? So from what I got, is I just clicked up on the area where yours is and I put 0.75, and then the Z-score I got was 0.674. We all good with that?
Yeah.
Cool. And a normal QQ plot.
It should be pretty easy, I think.
Yeah. F. Do we feel ready for the quiz, or do you guys want to talk about these QQ plots?
There's this one thing. So,
Yeah.
what did you get for E?
E?
Yeah.
Oh, for E I got, well, I mean, I wanted to check with the answers, but I got 0.1672.
Because they got 0.5698.
Oh, no. How'd they get that?
Looks like...
Let me see. Could you put it on your screen? Sorry. Thank you so much, Colby.
They don't show a graph for it, but
I like your shirt, by the way. Those are cool
Oh.
stripes.
thank you. So there's number E and solution.
Oh.
What did we do wrong?
I think I highlighted, we may have highlighted too much.
Oh.
I'm so glad you looked that up. Look, even up above we got F wrong. I mean we got D wrong. Oh, okay. So when we did D, or at least for me, what I had done is I clicked from the positive z-score, so I did the middle, I highlighted the middle of the graph and the left of the graph.
Yeah.
But when we calculated our z-score, it was negative 0.5, so we shouldn't have highlighted over negative 0.5. Does that make sense? We should have just highlighted like they have on the answer thing.
Yeah.
So we were really saying a different number. We were really saying like whatever positive 0.5, whatever that number is, that's what we were calculating with. So I think we did the math for E right, but what we plugged in for less than 150 or 1500 was wrong. Because it looks like they just did the answer from C minus the answer from D equals the answer for E.
Let's see.
Does that make sense?
It looks like what they're doing is like they were finding the area for let's see, for
in there.
1500.
Well, that should go in the fridge, but there's some warm chicken right there.
Also think so. Looks like they're.
Oh, on your foot.
It looked like they're finding the probability of, I guess, of it being 1500, below. So they shaded under, and then they, for 2500, for the probability, they shaded both.
Yeah, I think that's because, so for the 2500, we had a positive z-score, right? So it was anything less than that positive z-score and below.
Yeah.
For the 1500, we had a negative z-score. So we just shade whatever's below the z-score that we calculate. Does that make sense?
Yeah.
So I think that's why they only shaded the one section on the 1500.
Yeah.
Sorry, I was a little assumptive when we did E. I was like, oh, you just have to highlight them both. But I wonder if whatever the problem was in the individual reading thing, I wonder if both the z-scores were positive. So, of course, they always highlighted the same thing. Makes sense. I guess what I'm saying is what I thought was a rule must have been just for that situation in the assignment earlier.
Mm-hmm.
So, okay, so that makes sense, but they definitely broke it down there. Cool. Well, do you think we're ready for the quiz at least?
Yeah.
Colby, does it say on the answer sheet if D is normal? Because I see that, going down to the very last for F.
Oh, F.
Like A and B look definitely not normal. D kind of looks normal. Oh, you're right. You're right. Keep going to those graphs.
Yeah, it doesn't show anything, I don't think.
Oh, that's it. Okay.
It just says plot A, plot B.
Okay, that's boring.
F really starts right. Oh, geez, I won't let me.
Right there. Oh, yeah.
So that starts right there, but
Yeah, it looks like we're on the right page though. Or yeah, that looks good. Okay. Or do you guys have questions on F, or do you want to just jump into the quiz?
I don't.
Sorry, take your time and read it. Sorry. Didn't mean to jump too far ahead here. Hey babe, can you save me a leg? Thanks.
Oh, okay, so F is just you find a third quartile of the speeds, and then you find out if these. You also find out if these plots are, a normal density curve. Is that right?
Yeah.
Yeah.
Okay. Because I was a little confused about the third quartile. I guess it's two separate things it's asking.
Yeah, I know they should have made like another G or something.
Yeah, that's it, and then I'm fine with going on. I mean,
Yeah.
it makes sense.
The only thing is for D, do you guys think a D is a normal plot?
It seems normal enough.
I would say yes.
Okay. Cool. I just thought, yeah, all the other examples were like F, so it's like so obvious, but I mean, D looks pretty good too.
Yeah,
Okay.
I think.
I have a quick question.
Yeah.
So for these graphs, these QQ plot graphs, to decide, I don't know, it kind of makes me think of high school math. They have those stupid correlation graphs, and if the line touches more dots than not, it's correlated. You know what I'm talking about?
Yeah, I know what you're talking about.
So
I
my
think so.
question is, for these QQ plots, like, are you just supposed to fit the straightest line you can that touches the most points, or do you just draw a line from the very first point to the last point, and then whatever it touches, it touches? Like, how do you correlate it? You know what I'm saying? Do you know what I'm asking?
Yeah,
Yeah.
in the
Go
book
ahead, Coleman.
it says that you'll pretty much know if it's normal or not if it has like a sustained curve like A. If it has a curve like that, then you know it's skewed.
Yeah. So like,
What do you guys, and I remember it saying that it's fine if there is gaps in the lines, because I think an example of this is C, where it has kind of like it's going straight and then there's a little gap and then it keeps going in a little gap, and they're saying that's usually because it depends where they round. Like, let's say they only round to 1 decimal point,
yeah,
so you're going to see a gap in between the decimals or whatever.
yeah.
Mm-hmm.
So would C be like, I guess what you're saying, maybe if I understand you right, Brand, you're just trying to see is like, do we draw a line from like the first one to the last one, and then if it's relatively straight in between there, then it makes sense, or?
Yeah, that's what I'm saying. Is that how it is, or do you just draw a line that's straight that touches the most points? You know what I'm saying?
Yeah, I don't know.
Yeah, I don't know if the book really mentions goes into detail about it.
So do you think
Yeah.
you just eyeball it and just kind of like, well, yeah, it probably, according to the way it looks, it probably is, I guess.
Yeah, it seemed like it was pretty obvious. Like F was what they used as an example. Like, this is what looks good, and that's what we graphed.
Uh-huh.
D, I think, would be pretty good. I'm not sure about C, but definitely like they were like, this is what's very irregular, or not irregular, or not normal. I mean,
Yeah,
A, B, like very. So they didn't really explain for like close calls.
yeah.
It seemed like to me.
Yeah, most of them are pretty obvious. But I mean, like, I look at E and it's like it's got a lot of straight, but then again, it still has a curve in it, so it's almost like it could go either way.
Mm-hmm.
Yeah. Well, I think it should. I mean, if we get to something like that on the quiz, let's go over it. But I think it's typically going to be,
Pretty obvious.
yeah. I might ask her about C, but if she can answer, but.
Okay, yeah, that makes sense.
Awesome. Okay, have you guys opened it up by chance?
Yeah, I pulled it open on this.
Oh yeah, you're already there, Rand, huh? You've been there for a while. Okay, so just starting with number 3. The total area under a density curve must be equal to... Yeah, perfect. Under certain circumstances, a density curve can drop below the x-axis. No. A normal... What?
No, I was agreeing. You know,
Yeah,
it can
sorry.
drop the
A
exact
normal
same.
density curve is symmetric. Yes. Okay.
Mhm.
Use the following image to answer 6 and 7. Which of the following figures represents a z-score in this image?
Oh, Z-score? C,
Yeah.
right? C?
Yeah, C, right?
Okay.
Yeah.
Yeah, I think so. C.
Cool. Which of the following elements of the figure represents the probability that a random variable x will be greater than 1.1?
Raider?
Wait. Yeah. 1.0. Oh, that would be B.
Yeah, B. Right? Are we on
Uh-huh. I think so, because that's the area that would be over above the z-score.
Yeah. You there, Colby? You agree?
Yeah.
Okay. 8.
Okay, what would be... Hey, babe, do you mind taking it out of the fridge so it's warm when I eat it? The chicken? Oh, thanks. Cool. One standard deviation would be 68%.
Yeah.
Okay, suppose a random variable z has a standard normal distribution. Normal output to answer this question. What portion of the values from this random variable will be between -1 and 1?
Wait, are you guys on number 8?
Oh, sorry, no, I put 8, I put 68 because it's one standard deviation.
Oh, okay. Sorry.
No, it's okay.
Mhm.
Oh, I got a ton of Doritos because it's buy one, get one free. Okay, suppose z has a standard normal distribution. What portion of the values from this random variable will be between -1 and 1? So just click in the z-score 1. Is that what it's asking?
Mhm.
Isn't it 0.68%?
Yeah. It's got 0.6827. I
Okay,
think
so
the
it'll be
68 is, still close.
0.682, so it'll be 0.683. Right?
Yeah.
Suppose random variable z has a standard normal
Yeah,
distribution.
0.683.
Sorry. Okay, so 11. Use the normal aptitude. What portion of the values from this random variable will be between 3 and -3? Okay. Alrighty, let's type in a number 3 here. Wow, that's got to be a lot. Okay, so 0.997.
Hey, what was number 10? Sorry.
I'm doing it right now.
Oh, you're doing number 10 right now? Okay.
Yeah. Oh, I skipped it. Sorry, no, I was doing number 11. Sorry, I thought.
I was just like, holy crap, that was fast.
Yeah, sorry, my bad.
No, that's good.
So, well, the answer for 11 is 0.997. The answer to 10, I don't know.
Do we have to round on these?
To the third decimal point.
And okay, and do we round up if possible?
Like what one?
Like say you had 0.6839, you'd make it 0.684. You know what I'm saying?
Yeah.
Okay.
So for this number 10, I got 0.9545. So are you guys going to put 0.955, right?
Yeah.
Yeah.
Look carefully at your answers to the last 3 questions. What do you observe?
Ooh, I'd say A.
What does A say for you?
The values match 68, 95, and
Yeah.
99
Yeah.
cents.
That's perfect. Mine's that's C for me. So I looked at A and I was like, I think ours must be switched up.
Okay. You good?
Yeah, so 13. The amount of protein an individual must consume is different for every person. Sorry, I don't mean to always be the one to read. I just can't really process it without reading it out loud.
No, it's fine.
Okay. There are solid theoretical ideas that suggest that the protein requirement will be normally distributed in the population of the United States. The protein requirement is given in terms of the number of grams of food, quality protein, grams of good quality protein that must be consumed each day per kilogram of weight. The population mean is 0.66 grams, and the population standard deviation is 0.07, all that stuff. Use this information for questions 14 and 17. So the mean is 0.66, and the standard deviation is 0.07. What portion of the population has a protein requirement that is less than 0.6? So you just plug in 0.6 as the x.
Okay. And then minus 0.66, right?
What?
Plug in 0.60 for the x, right? And then minus 0.66
Yeah.
and divide by 0.07.
Yeah. So I got 0.85, and then we plug that in. What is that asking? Less than that. So.
Yeah.
But it is positive, so we would shade the middle part too, right?
So what did you get for the answer?
I just got 0.8043. What'd you get? What did you get, Colby?
Oh, the proportion?
Yeah.
Is that what you're talking about? I got 0.1957.
Oh man. Okay. So what was your z-score? What was the z-score that you put in?
What's that?
What was the z-score that you put in?
I got negative 0.8571.
Oh, you know what? I think I dropped a negative. Yeah, so mine was wrong. So let me go look again. Okay. Wait, what did you get? So I got, let me see. So I got 0.6 minus 0.66, right?
Yep.
Okay, and then you divide that by 0.07. So I got my z-score as negative 0.8571.
Yeah.
So then when I plug in, did you get that z-score? No.
Yeah, I believe so.
Okay, that's
You
the,
got
yeah.
0.8571.
Yeah, so I just plugged that new one in, and I got that same probability you did.
Mm-hmm. Okay.
Yay, better. So the answer is 0.196, right?
196.
0.196. Okay, how many questions is this?
I think we're
Oh,
almost
we're almost there. Okay. What portion of the population have, wow, that's a lot of P's in one sentence. What proportion of the population have a protein requirement that is less than 0.7? So it's going to be 0.04 divided by 0.07. Right? Or did you guys get that?
I'm just in right now.
Sorry, I was just doing the z-score math out loud.
You find the z-score for 0.7 and then subtract it, kind of what we did earlier.
Exactly what we did earlier, yep. Let me know what z-score you guys get.
Okay, just like plugging it in.
I got 0.5714.
Yeah, that's what I got too.
Okay, what did you guys get?
0.5714.
Yeah, that's what I got too.
Yay, okay, so plug it in, and then we should have the middle and the tail, the left tail highlighted because it's a positive z-score.
Okay.
So you put that in for the z-score on the left or the right side, does it matter?
Well, when you put it on the left or the right, it will automatically put it on both. So it doesn't matter where you put it in, but when you read it, you want to make sure you highlight, because it's a positive z-score, you want to make sure you highlight all the sections underneath the positive z-score. So the middle and the left side.
Oh, okay. And so in the area, did you get like 0.716?
Yeah, exactly. And then if you're going to have a negative z-score, you would, if like let's say our z-score was negative 0.5714, you would just unhighlight the middle, and then it would just be below that. Okay, so 16. To find the area between the two values, you can track the area to the left of each of them. So it's pretty much essentially saying between the two.
Yeah, this is the last one of the last problems from the preparation.
Yeah, it's just like that, huh?
Hey, what did you guys get for 14, real quick?
14.
Yeah.
Oh, you know what, you guys? I don't think we did 14 right.
How'd you do that one?
Well, because I'm just reading again, it says what proportion of the population have it more than 0.6 grams?
Yeah.
And I think we highlighted what was under 0.6.
Oh. I ended up getting 0.804. I just took 1 minus whatever.
Oh, good. Okay, yeah, I just put in the wrong thing. So what is the answer then?
I put 0.804.
Yeah, I'm sure that's right.
Well, then for me, oh wait, okay. So wait, what's your answer for 13?
I got 0.196.
Yeah.
And then your answer for 14 is 0.804.
Yeah.
Yeah.
Oh, I switched them. Okay, so 196. Okay, 1. Okay, so 13 is 0.196 and 14 is 0.804. Okay, we're on the same page again. So do you just minus 15? Do you just minus 13 from 15?
I don't know. I probably have to do it on the app just to make sure.
Okay.
Let's see. So,
you guys understand what number 16 is asking then?
I think it's kind of asking like the question on the prep that was like you had to find between the two.
Mm-hmm.
But to find the area between these two values, the 0.7 and the 0.6, you can subtract the areas to the left of each of them. So what would be less? The left of, so if we have a z-score and if it's to the left, then it's going to be what would be less than that point. So less than 0.7.
Yeah.
So I'm thinking if we subtracted 15, which is the area that's less than 0.7, and then 13, which is the area that's less than 0.6, I think that would be the area in between.
Oh.
Let me know what you guys got. I got 0.52. But I just did it by
0.5203.
Yeah.
That's what I got too.
So we put in 0.52. Oh.
Yeah.
0.520.
Yeah.
Yeah.
520.
Hey. I think we did it. Are we ready to submit?
Oh yeah, I guess so.
I'm like, it's almost. Yay!
Good.
Nice job, my friends.
Good job, you guys.
Okay, so we just have the homework that's due on Saturday for each of us, and then we'll have another group meeting on Tuesday.
Yeah.
Do you know when we have exams for this class?
I don't know.
I guess we'll find it in a folder.
Yep.
Pretty much.
Awesome. Okay, well, I hope you guys have a great night. Thank you so much. Colby, thanks for trying to come early, guys. Sorry I didn't come back much earlier.
No problem.
No problem.
Okay, thank you, though. Okay, I'll talk to you guys soon.
Okay. Thanks, guys. We'll see ya.
Okay, bye.
See ya.